Hey guys, today we're learning about chapter 8.2, special right triangles. Now this lesson is super important. We're going to spend 2 days on this. This is a base for anything that we do in trigonometry and pre-cal. And so if you are confused or have questions, it's super important that you ask and you get help and that you know what's happening and know why we're getting certain answers or certain responses for each of these questions. So this is really important. I want you to treat it as such. And yeah, so we're going to get into it. This is special right triangles. So we're talking about two special right triangles and their properties and essentially their patterns. So the first one that we're going to deal with is 45, 45, 90. So the measures of the angles in all of these triangles will be 45, 45, and 90. And so every single triangle that has those angle measures will have this property, these patterns, okay? So first thing we want to think about is how is the hypotenuse related to the legs? If it's an isosceles triangle, which we know it is because two of the angles are the same, so 45 and 45 are both the same angle measurement. That means that their sides are also the same. Their sides, the little L's, those are the same measurements because they're across from the angle measurements that are the same. So my question is, how does the hypotenuse relate to the lengths of the legs? I mean, we could do Pythagorean theorem every single time, but that's going to get really old after a while. So instead, we need to make sure that we are can find a pattern if there is one. So we're going to do an example where the length of each leg is 1. So we're going to pretend that each of these legs are 1. Okay, so let's just do a little Pythagorean theorem. We've got 1 squared plus 1 squared equals h squared. We don't know what h is yet, but we know each of the legs is 1. So 1 squared is 1. 1 squared is also 1. So I've got 1 plus 1 equals h squared. Well, 1 plus 1 is 2. 2 equals h squared. And we know to get rid of a square, we have to square root both sides. So my final answer is radical 2 or root 2 equals h. So if each leg is equal to 1, then my hypotenuse is root 2. So I'm going to write that over here off the side. 1, 1, root 2. Okay? We're going to do the exact same thing, but we're going to do a different side length. So now we're going to pretend these aren't 1. We're going to call them 3. So I'm going to call them 3 and 3. Okay? Exact same process. 3 squared plus 3 squared equals h. And you may be asking, Miss White, why are we doing this? Again, like I said, we want to see how is the hypotenuse related to the legs. So we're doing two examples to see if we can find a pattern. So 3 squared is 9, 3 squared is 9, equals h squared. 9 plus 9 is 18, equals h squared. Well, good thing we've gotten super great at our factor trees off to the side. So I'm going to do 18, and that becomes 2 and 9 is 3 and 3. Whenever you have a match, you get to take it out. So I get to rewrite this as 3 radical 2 equals h. Oh, I forgot to show that you square root both sides, but I think we were all on the same page, right? Square root to get rid of a square. All right, so then in this example, if each leg is 3, I've got 3, 3, and I've got 3 root 2. All right. So now we're going to figure out and see if there's a generalization that we can make for this. Your book calls it Theorem 8.8. That doesn't matter. What matters is this pattern that we have. So in a 45, 45, 90 degree triangle, we can write a ratio of the leg to the hypotenuse as x, 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 root 2. I'm going to remind us what our practice was before. We had 1, 1, root 2, and we had 3, 3, 3, root 2, right? I can even go back to the last slide and show you that those were our answers. So in a 45, 45, 90, whatever the lengths of the sides are, the hypotenuse is that number times root 2. 1, 1, 1, root 2, 3, 3, 3, root 2. You put any number, decimal, whole number, fraction, whatever, and that's the pattern it would be. Okay, so a generalization to find the hypotenuse, you just do radical 2 times the leg. Okay, So if we look at this example I have off to the side, I'm going to label each leg just a general x. X can be any number. It can be 5, it can be 100, it can be 2 root 7, like we don't know what it is, but whatever number that is both of the legs, because they're congruent to each other. And then the length of the hypotenuse is the length of the leg, x, times root 2. All right. A quick thing that I like to note is that if you are going from the leg to the hypotenuse, you're multiplying by root 2 because we want it to be bigger. The hypotenuse is bigger than the leg, so to go from the leg to the hypotenuse, we want to be bigger. And if we want to go the opposite way, if we're going from the hypotenuse to the leg, we're going to divide by root 2 because we want to go smaller. The legs are smaller than the hypotenuse, so we have to divide to make it smaller. Okay? That's just a little thing I like to think about. So you multiply one direction, you divide the other. We're going to do a couple examples, so don't freak out yet. My next question is, why is every 45, 45, 90 triangle similar to every other 45, 45, 90 triangle? Well, you remember there's, I think, 3 different ways that we can tell that triangles are similar. We have SSS similarity, we have AA similarity, and then we have SAS similarity. Well, just based on this information, we don't know anything about the sides, but we know that at least 2 of the angles are congruent. So by AA, then all the triangles are similar. So that's a fun little thing to kind of combine with what we have been doing. All right, now we're going to do some examples. So I've got these problems right here. We're going to start with this one right here. I'm going to call it number 1, just so you know what I'm talking about. If I am on this one, I already know that I've got a 45, 45, 90 triangle because this angle is 45, that makes this angle 45, and this is 90, okay? Knowing that, I'm allowed to figure out what the legs are because I know the hypotenuse. As I said on the last slide, if you're going from hypotenuse to leg, you're going to divide by root 2. So we can think of this as like 9 root 2 divided by root 2. The roots cancel, and I'm left with 9 for each leg, 9 and 9. Which would make sense if I was going back the other way. If each leg was 9 and I was going the opposite way to get to the hypotenuse, you'd multiply 9 by root 2, which makes sense that my answer is root 2, 9 root 2. All right, let's do another example. All right, this one, again, I know it's a 45, 45, 90. 45, this has to be 45, that's 90. All right, cool. We're all on the same page. Now I have a leg, and I'm going to go from a leg to the hypotenuse. If I'm going leg to hypotenuse, we're going to multiply by root 2. 8 times root 2 is going to be 8 root 2. The other side that I have to figure out is y. Well, 8 and y are both legs. They're congruent to each other. So y is equal to 8. 8 root 2. And then the last one of this kind, or I guess not the last one on this row, whatever, is another 45, 45, 90 triangle. 45, this has to be 45, 90. Just because this angle right here doesn't say 45, we know that the sum of the angles in a triangle are 180. Yes, I hope you answered that with me. So if you already have 90 and 45, 180 minus 90 minus 45 is 45. So that's why this works, and I can just assume that that last one's 45. Okay, this one looks a little funky. I have a leg here. One thing I haven't really talked about on this video yet, but I think we should know, is that the hypotenuse is the easiest thing to recognize. It's the side that's across from the right angle. So this is my hypotenuse, which makes my other 2 legs. I'm sorry I didn't mention that before, but now I am. So we have a leg. That means that the other side that I already know is y. That's got to be 4 root 6. It's the same thing as this leg that's already given to me. No math needed, just copy it down. And then in order to find x, I'm going from leg to hypotenuse, so I'm multiplying by root 2. Well, if I have 4 radical 6 times radical 2, what do? Well, first we're going to multiply the two radicals together. Radical 6 and radical 2 multiply to be radical 12, 4 radical 12. Well, that's ugly. That can be simplified down. Radical 12 breaks down to 2 and 6 and then 2 and 3. So that's 4 times 2 radical 3. We got a pair of 2's, so those come out and the 3 stays behind. And then now that I've got two numbers outside the radical, you can multiply those together, which gives you 8 radical 3. Sorry, this isn't very neat, but that goes up here. 8 radical 3. Again, multiply by radical 2 to your 4 radical 6, and this work all along the side shows you exactly how I got there. All right, before we look at the last example, I want to do a quick review. It says, review rationalizing the denominator. We did this last week, I know we did, on one of our iStep review sheets or on one of our worksheets in class. If you have a radical in the denominator, we have a problem. So you need to multiply by that radical on top and bottom in order to get rid of it. I don't want it. No radical in the denominator. When you multiply by root 2 on top and bottom, I'm going to get 12 radical 2 on top, and I'm going to do root 2 times root 2 on bottom, which is equal to root 4, which we know is the same thing as 2. So root 2 times root 2 is a normal 2. And then I get to simplify. I've got 12 and 2. I know that they both have a factor of 2, so that leaves me with 6 radical 2. Okay, that was just a review. That doesn't really go with anything, but I'm going to need that skill because now, looking at my last example, number 4, I have what looks like, well, which side is this? I'm going to label my hypotenuse first because it's across from the right angle because I think that's the easiest to find. Oh, shoot, I have my hypotenuse. My hypotenuse is 10. There's not a radical I can just divide off easily. I have to do 10 divided by root 2 and see what happens. So if I do 10 divided by root 2, we have to rationalize our denominator. That's why we just practiced that last step. Multiply by root 2 on top and bottom. That gives me 10 radical 2 over 2. My 10 and my 2 cross out to become 5 radical 2. And so both of my legs, x and y, are 5 radical 2. At this time, I'd probably pause and maybe try a couple of your 45, 45, 90 triangles on your homework, and then come back and join me as we go over 30, 60, 90 degree triangles. So again, pause, practice, and come back to me. All right, and now that you're back, we're doing properties of 30, 60, 90 degree triangles, which look a little bit different than what we were just doing last step. So again, these are 30, 60, 90. The other ones were 45, 45, 90, very different. And these are based on their angle degrees. Now, is this an isosceles triangle? The answer is no, because none of my angles are the same. 30, 60, 90 are all unique angles, and so I don't have two legs that are the same. So we're going to talk about the hypotenuse, which I think is the easiest one to recognize. And then we've got the short leg, and then we have the long leg. The short leg always goes across from the 30-degree angle. So the short leg goes with the 30-degree angle, and the long leg goes across from the 60-degree angle. And then, as we already know, the hypotenuse goes with the 90-degree angle. So those are kind of special things for us to recognize. It says start with an equilateral triangle that has sides of length 2. So that means all of my sides are 2. 2 and 2, and then technically this distance A to C is also 2. We then dropped an altitude, which if you remember from, I don't even remember what section it was, right maybe around Christmas time. An altitude is a segment that goes from a vertex to the opposite side that makes a 90-degree angle. So we drop an altitude from B to its opposite side, and so now we've got 90-degree angles, and we've got little triangles. So I've got a little triangle over here on this side, and then I have its exact reflection, its exact twin on the other side. So by splitting this equilateral triangle, now I've got two 30, 60, 90 triangles, which is great. Okay, so we're just going to focus on the one that's ABD. Oh, I did not mean to do that. We're just going to focus on the one that's ABD right here. So we've got a 30-degree angle, we've got a 60-degree angle, we've got a 90-degree angle. Across from the 90-degree angle, we have our only angle measure, or our only side measure that's given to us. That's 2. So my hypotenuse in this situation is 2. We also know what's across from my 30-degree angle by process of elimination. So across from my 30-degree angle is half of the side AC. Well, if we know all of AC is 2, then half of that AD is 1. So my short leg is technically 1 unit. Now, in order to find my long leg, we're going to have to do Pythagorean theorem. We know that the hypotenuse is the longest side, so it goes by itself. We can do 2 squared by itself over there. And then everything else will be A and B. It doesn't really matter which one you do. We'll just put 1 right here for the short side, and then the long leg, we don't know what that is. So I'm just going to call it, let me call it L for leg. L squared. That's a fancy L, not a 1. So now I'm going to do my math. I've got 1 squared is 1 plus L squared equals 2 squared, which is 4, minus 1 from both sides. L squared is 3. And then remember, we have to do square root of both sides. Square root. L is equal to, well, radical 3 doesn't simplify down. So that is my answer. In this example, my long leg is radical 3, root 3. Now, we don't have a pattern yet. If you remember back in our 45, 45, 90-degree triangle, our pattern was x, x, x root 2. Our pattern here isn't going to repeat our x's, but it will have at least one x. And I think it's easiest to have your x be with your 30-degree angle, your short side. So your short side is going to be what we call just x. Everything else is going to be in response to x. So they are both whatever the value of the side is now times x. So the hypotenuse is going to be 2x, and then the long leg is radical 3x. So this is the pattern that we are going to use. And I'm going to rewrite this in a prettier form on the next slide. So again, another theorem. I don't need you to know it's 8.9. It just is dealing with 30, 60, 90 triangles. And its ratio goes short leg, long leg, hypotenuse. And like I just said in the last slide, we use the short leg, that's our x. Everything's in reference to it. The long leg is x radical 3. And then our hypotenuse is 2x. So I'm going to fill it in on my picture. Across from the 30 degrees is my x. Across from my 60 degrees is my x radical 3. We put the radical 3 behind it. They're being multiplied together. That's just the prettiest form of it. So you can jump over here and think of the long leg as equaling root 3 times the short leg. And then last but not least is my hypotenuse. So across from the right angle is going to be 2 times x. The hypotenuse is 2 times the short leg. Everything is referenced to the short leg. Remember, so I'm reading this right here, remember the shortest side of the triangle is opposite the smallest angle. So the shortest leg is across from the 30 degrees. The longest leg is across from the 60 degrees. I said that a couple different times, but make sure that we know that 30 is shortest, so 30 and x go together. 60 and root 3 go together. Sometimes I remember things by thinking that they're not what I want it to be. I want the root 3 to go with the 30, and it doesn't, so I have to remember that it goes with the 60. So you have to remember that x root 3 goes with 60 degrees. That needs to be like embedded in your brain by now. I can't write any more exclamation points. I'm trying. Okay. All right, so now we're going to get into a few problems, and then you're going to do more practice on your own. So it looks like I've got 5 problems here. We're going to go for it. So it says find the missing side lengths. The first one, I gave us a softball. We started with the short side. So I gave you the side across from 30 is 2 root 3. This, I know there's root 3 there, but it's across from 30, which makes that my x side. The side that's across from the hypotenuse is your 2x side. The x in the equation can sometimes confuse you, but I would just like, if you need to just cross the x's and the y's out and just know what the short leg, long leg, hypotenuse are, that's fine with me. And then last but not least, the side across from the 60, which is the missing angle, is x radical 3. So if I know that x, or I know my short side, I'm going to go down here and I'm going to label my short side, I'm going to label my long side, and I'm going to label my hypotenuse. My short side I already know is 2 radical 3. If I want to find my hypotenuse, which I think is the next easiest thing to find, I'm going to do 2 times 2 root 3. So 2 times 2 root 3. Remember, when we multiply with the radical, you only get to do it to the non-radical number. You don't also get to do it to the radical, so don't do that one. Just do times the non-radical. So that gives you 4 radical 3, and that's your hypotenuse. And then the last one's the long side, and you're just taking x and multiplying that by root 3. So I've got 2 root 3 times root 3. Radicals get to multiply together, so root 3 times root 3 is root 9, or just a normal 3, so this is essentially 2 times 3, which is 6. Okay, so those are my final answers. One thing I do want to go back to really quick, I think this might be helpful. I did this on the last slide. But remember, when you're going from smaller to bigger, like if you're going from the short side to the hypotenuse, you're multiplying by 2. If I'm going from the short side to the long side, you're multiplying by root 3. If you're ever going from a longer side to a shorter side, you're going to divide. So if I'm going from the hypotenuse to the short side, you're going to divide by 2. If you're going to go from the long side to the short side, you're going to divide by radical 3. I personally never go this direction. There's no easy way to do it, so I just kind of root my way around. If I have to go from the hypotenuse to the long side, I go to the short side, and then I go to the long side. So maybe not the easiest way, but I just don't think that this is a good pathway to take, so take a different path. Reference back if you're doing the green path or the blue path in the future, okay? I'll try and do that from now on. When I was going on example 1, I went from the short side to the long side, multiply, short side to the hypotenuse, multiply. Okay, if I'm looking at the next example, my side that's given to me is the hypotenuse. It's the side across from the right angle. That's your 2x side. The side across from the 30 is your x side, and the side across from your 60, which is the non-existent angle, is your x root 3 side. So first thing I'm going to do is I'm going to go from the hypotenuse to the short side. Hypotenuse to the short side, so I'm going to divide. We're going to divide by 2. So to get my short side, I'm going to do 12 divided by 2. That gives me 6. So my short side here, it's b, but it's also 6. I don't know what my long side is. That's my next journey. And then my hypotenuse was given to me, so that's 12. To get from my long side, like I said, don't go on the path that goes from hypotenuse to long side. Don't take that path. Instead, I just found my short side to be 6, so I'm going to multiply my short side by root 3 in order to get my long side. So I'm going to do 6 times root 3. Well, 6 times root 3 can't be any simpler. It's just going to be 6 radical 3. The names of these sides, short side is B, long side is A. I don't know if that helps kind of keep everything straight in your head, but there's a lot of pieces going on, so be careful, be patient. All right, 2 more examples. This next side that's given to me is the long side. I know that because it's across from the 60-degree angle. That's not written there, so it's x root 3. I know that little b is also called x because it's across from the 30, and I know little a is my hypotenuse, and so I'm going to label it 2x. Let's get to the short side first. So we're going to, when we go from long to short, we're going to divide. We're going to divide by radical 3. So if I have 5 radical 3, divide by radical 3, cross out, short side, little b, x, whatever you want to call it, is going to be 5. Short side is 5. Long side was already given to me. That was 5 radical 3. And then hypotenuse is what I'm going to find next. This is little b and this is little a. Again, keeping everything straight. If now I want to get the hypotenuse, I'm going to go to from the short side to the hypotenuse by multiplying by 2. So I'm going to do 5 times 2, and that's a simple multiplication of 10. All right, keep rolling. Next example, it's across from the 60 because it tells us it's across from the 60. So I'm going to label this side x root 3. The short side we're just going to call x, and then the hypotenuse we're going to call 2x. Again, I know they're already labeled x and y. Sometimes that confuses me. I think it's super important and more important to write x and 2x instead. So that's what I'm going to do. All right, easiest is to go to the smaller side. So if I have the large side, long side, and I want to go to the small side, I have to go by dividing. We're going to divide by root 3. If I do root 6 divided by root 3, what's that going to be? Well, just like multiplying, you can divide your radicals. 6 divided by 3 is root 2. Because you can divide terms outside the radical together and divide terms under the radical together. So my short side x is root 2. And then in order to get my hypotenuse, we're going to multiply by 2. So root 2 times 2 is simply going to be 2 radical 2. Again, if it's under the radical, you can multiply it with anything under the radical, but not with something that's outside. So your best answer here is root 2, 2 root 2. All right, so let me write it in my nice organized form. My short side is radical 2. My long side was given to me, and that was root 6. And then my hypotenuse is 2 radical 2. And then again, if you want to stay organized, your short side was technically y, and your hypotenuse was technically x. And then last example, they gave us a hypotenuse, a good one to end on. They gave us a hypotenuse, which is the same thing as 2x. If we want to find the short side, which is x, and then the long side, which is x root 3, we need to do the short side first. Always go through the short side. In order to go from the hypotenuse to the short side, we need to divide by 2. So I'm going to do 8 root 3 over 3 divided by 2. Wow, that is ugly. If you think of this as divide by 2 over 1, then we can multiply by the reciprocal. We can do 8 root 3 over 3 times the reciprocal, which is 1 over 2. Then we've got some cancellations. The 8 and the 2 both have a common factor of 2, so I'm left with 4 root 3 over 3. Still ugly, but this is our new x, our short side. Let me write that off to the side. Short side equals 4 root 3 over 3. Long side, we don't know yet. And then the hypotenuse was 8 root 3 over 3. In order to find the long side, we have to do the step of going from the short side to the long side by multiplying by root 3. So if I had 4 root 3 over 3, I have to multiply that by root 3. We know root 3 times root 3 is root 9, which is 3. So I essentially have 4 times 3 over 3. That becomes 12 divided by 3. And 12 divided by 3 is 4, or you can take out the factors here and go to 4 immediately there. So my long side is 4. Whew, that was kind of ugly. Again, this is kind of tough stuff. This is super important. Please ask for help if you need it. Please try your worksheet. I'll be available via email or Google Hangout or Meet or whatever you want to call it during class and during Flex. I don't see you guys tomorrow on day 6, so this is all due, and we'll do our second day on this stuff on day 7, which I think is Thursday this week. Have a good rest of your day, guys. Bye.